I'm fixing it. I'm filming it. Well, hello everyone. Today we got a bit of a project on our hands. Co-worker's having problems starting his 2007 Brute Force 750 Cowie, and he brought it over to my garage to see if I can track down why it's not starting. There were so many things to test on here. I took the time and removed all the panels to make it easier. Likewise, we want to spruce it up. He just got this used, so we want to paint the metal racks and shine up the plastic. So take it all off. So this is the problem. And basically we get one spark and that's it. So I got a flow chart from the service manual, and we're going to follow it and we're going to go through it all. I've already done it, and it's leading up to a igniter, but I'll show you that later. Okay, so I'm going to show you what happens here. What the symptom is. Basically, I'm just getting one spark. So I'll turn off the lights so you guys can all see it. Okay, we'll turn the key on. See, just the one spark. Okay, so I've already confirmed the spark plugs. They are gapped to what they should be. 28 to 31 thousandths of an inch, or 0.7 to 0.8 millimeter. Why don't we look at the spark plug? I have a tester. Let's see if it's working. These are new plugs, but you never know. Okay, let's check out the spark plug. Brand new. It's gapped. Let's see what it does. Lots of spark. Lots of spark. Okay, the next thing we're going to check out is the coil. Coil, and actually the spark plug wire from the coil to the spark plug. So we got two connectors here, a clear and a black, and I'm just going to mark this one as white so I know. So that's for the front spark plug, and I'll show you where the coil is for the rear spark plug. Okay, and then the coil for the rear spark plug is right there. You can just barely see it. That's where the coil is for that one. So let's test them both out. Okay, so I got the coil off, and here it says we can check the primary winding, and that would be these two connectors. So it says to set your tester to ohms range. So let's go to ohms. That's the little horseshoe. Let's get it to what it wants, normal ohms, and it says I should get 0.09 to 0.13 of an ohm off of the primary. I'm getting 0.6, so that is within range. I can go from 0.09 to 0.13, and that is within range. So that's good. So the primary winding is good. Now the secondary winding, I got to go a little bit higher maybe. Let's go to K. There we go, K. And it says I should be getting 3.8 to 5.8 in the secondary. So the secondary is basically your spark plug in to one of the terminals. Maybe I gotta go a little bit. There we go. So I'm getting 9.3 K. Well, that's a little high, isn't it? 9.3, 9.3 on both of them. So again, one connector here. So that is a little bit out of spec. I should be getting 3.8 to 5.8. Also, another way to check too is this has got some resistance too. So you can unscrew it. Pull as you unscrew, and this should be about 5K. Yeah, I'm getting 4.85. So that's about right. So if I subtract that from here, $4.4. Okay. So that's what I should be getting. Remember, you got to take this off in order to get a proper test on here. 4.4, and that's within readings. 3.8 to 5.8. Okay, so that's what that little diagram means. You got to take this off, and this will be about 5K. So let's screw it back on. Let's see if we have it properly connected. Yes, back to our same reading of 9. Okay, so the coil is good. I checked the other coil, same thing. Coil's all good. Okay, so far we are progressing pretty good. Faulty ignition, no spark. Well, I'm getting one little spark. Battery, I have a battery charger on it, so it's not the battery, plus it's a brand new one. Ignition system wiring and connector, I've gone through that, it looks good. Spark plug inspection, we did that, that's good. The plug gap is good. The primary and the secondary on the coils are awesome. What's next? Vehicle down sensor inspection. Let's take a look at that. Okay, so the vehicle down position sensor is this guy right here. Okay, and this is the connector for it. So let's see what the procedure is to test that out. And I'm getting all my information from the service manual. So basically, it is telling us to do some measurements here. So I'm going to take the connector off. The lead connector is a harness side. So let's see here. Turn the ignition on and measure the power source. Okay. So let's disconnect it. Okay. And basically B will be my positive side. So I've got to put it to here. Well, first of all, let's get the meter going. It says to put it at 12 volts DC. So that's that guy. Straight line. 12 volts. So, take this connector. This is from the harness. This is from the sensor. Okay, so let's see here. From this side to this side, we should be getting 12 volts. There you go. Okay, from that side to that side, we should be getting 12 volts positive and 11.8. Okay. So let's turn it back off. What's the next test? Okay, the next test is I should be getting 5 volts with the center one. So it looks like this outside one is so outside one and then the center one. Yes, I am. I'm getting 5 volts, just like it says. Okay, so let's connect this up. Okay, so now, with the sensor in its proper position, marked up, and you can kind of see it in the black, I should be getting 4 volt to 1.4 volt. So from the ground to that center, I should be getting that voltage. And I've already pinched my wires a little bit to get my probes in there. Make sure you tape them up. And what am I getting? I'm getting 0.74. So that's within range. 0.4 to 1.4, and I'm getting 0.74. So the rollover sensor is good. Let's get on to the next test. Okay, the next test is, let's make sure the crank position sensor is working, and it comes out of here as well as your stator wires. But let's go check that. So that's this guy right here we want. It goes to the other side. Okay, and just follow your wires. And this is where it goes. So right here, this is your main stator alternator. Should be 3 black wires, yes. And right here is that sensor for the crank position. So let's disconnect it and measure that. Let's measure the resistance. Okay, so that resistance should be 423 to 517 ohms. So let's measure it. Okay, let's get this to ohms. There you go. And let's measure that sensor. I'm getting 422 ohms. That is within spec. Well, so far things are testing out. Anybody wants to know what this is? This is your actual temperature sensor. This is a carbureted model still, so it's like little heaters on the carburetors if it's in cold weather. Okay, so for the heck of it, why don't we check out the stator? Let's make sure nothing is shorted on that. And that's this connector right here. There we go. We should get the same 3 readings on that. Okay, so to actually test out the stator, it doesn't want to run. So obviously it says at 3000 RPM, you should be getting 38 to 58 volts, but we can check the resistance on it. And when I go to every connector, I should be getting the same. And it says right now, I should be getting 0.29 to 0.43 of an ohm. So let's test that out. Let's see what we get here. 3 black wires, and each one to each one I should be getting the same. 0.9, 0.8, 0.9, 0.8. So it's a little out of spec, but it's consistent. So that's good. The stator's good. Well, we can check one more thing, and that'll be the stator. And the stator's in the very back of this machine. Here's the stator right here. So let's get this disconnected and see what tests we can do with it. That's what that looks like. So basically, this is what we're going to try to do here. That's all we can really do, unless I want to start applying voltage to it. But let's just make sure we get everything out. It says the resistance should be low in one direction and more than 10 times in the other. Well, what we can do is do a diode test, because that's what the rectifier has. It's diode. So we should only get a diode test going in one direction and not the other direction. So right here we want to go from white to B1 to B2 and B3, and we can reverse it. So this is what I'll show you. Let's get to diode. On my machine it's blue, but that's a diode right there. So let's get this, and you should have something called NF come up, microfarad. So it says basically from white to all of these I should get. So we'll put the positive on this, and we should get 1.25. One point six. 1.6. Now, if you reverse it, you should not get anything, because diodes only let power flow in one direction. So there you go, overload. Let's go to the next one. Overload. Overload. Okay, so we know it's working. Now it says I can test the other terminal, BKY, this far one. Okay, so the next test is to go to the other side here, and let's see if I get a reading. Yes. 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 Okay, let's reverse these. Remember, a diode only lets power go in one direction, so I should be overload on each one. Overload. Overload. And overload. Well, there you go. So this rectifier is good. Now, I did more tests than what I needed to, just to confirm, because it's not looking good for me. So I've done everything here, and I've done more. I've tested out the rectifier, I've tested out the crankcase sensor, I've tested out the stator / alternator. And what it says the igniter is defective. Replace igniter. Some people call it a CDI, but Cowie calls it an igniter. You want to see where that part is? Let's go take a look at it. Here is the igniter. So they're saying that this could be bad, which is too bad, because that's a $500 Canadian cost. I've gone through the forum and all that, and I've reseated all of my connectors. I have even lifted up this fuse panel to see underneath it to make sure nothing is corroded, and it's all looking good. So looks like an igniter, which is a shame. People wondering, well, these two wires, well, this went to a little relay for your fan. It broke off, so as long as you put a 15 amp fuse between these two, that's okay. But everything checks out, so let's phone Cowie and let's get this part replaced. 3 connectors, there you go. In the meantime, while I'm waiting for this, I'm going to go through all my connections and put dielectric grease on it. And that way, well, at least I know they have good, as best connection as possible. Well, we finally got the part. Took 3 weeks to get here, but it got here. Dynatech. So after going through all of the troubleshooting, the flow chart from Kawasaki says it's this guy, the igniter / CDI box. Contacted Kawasaki, and this box is over $500 Canadian. And I tried a few places and they all were the same price. So I'm on the old 750, 650 brute force Facebook page, and a lot of guys are talking about this, the Dynatech. So I started phoning around for that. 3-week back order in Canada, and that's going back a couple of weeks ago now. So I ordered this from the States. It took over 2 weeks to get here. Ended up costing $300 Canadian and $25 customs charge, and that is effective October the 1st, 2021. But we had no choice. I was reluctant to get that. It's a lot of money, but after following all of the flow chart, it ended up always coming to this guy. So we're going to replace this guy. So first things first, we have to undo the battery, which I've already done. Let's get rid of this guy here. This just lifts up. Let's throw that away. That's about 2/3 the size. But before we throw this one away, we need this case. Now I would normally put dielectric grease on here, but why don't we just get this plugged in and make sure it works. Then I could go back through all the connections, do dielectric grease. Okay, that was simple plug and play. Go, everything connected. Let's see if this thing starts. Oh, let's hook up that battery. It's not going to start too well with that on. 10 millimeter. Okay. Yeah, we always had that. That was it, folks, that Ignitor CDI box. How many countless of hours did I spend going through every connection, following the manual to check out the resistance and ohms and voltage and everything, and it ended up being that. Obviously the most expensive part, I had to go through the cheaper ones first. It does a lot of neat things. It takes away your rev limiter, your reverse limiter, so it's cheaper. It'll probably last a lot longer than the original OEM part. But anyways, guys, okay, I'm going to go through all the connections now, dielectric grease, and then let's start buttoning this thing up, put the covers back on. Okay, now that it's running, I'm going to go through every connection and put some dielectric grease. And there's quite a few connections. I'm not going to bore you, so disconnect the battery. And any connection you got, rip it apart, put some dielectric grease on it.